All right. Hello, everyone. Well, is it great? Okay. My name is Carice Graby. I am the chemistry club president for this semester. Along those lines, if you are interested in joining a chemistry club meeting, our next one will be this Wednesday at 12:15 over in Bradley 207. We'd love to have for you to join us. So today, I'm excited to welcome you to our third Careers in Science lecture of the semester. And I'm excited to introduce our speaker, Dr. Robert Gillette. Dr. Gillette has extensive experience with dogs and canine performance, including over 30 years of veterinary clinical experience, research in canine performance, and working dog large kennel operations. He got his doctorate in veterinary medicine at Kansas State University and his postdoc in kinesiology and exercise physiology at the University of Kansas. In 2011, he became a charter diplomat of the American College of Veterinary Sports Medicine and Rehabilitation. He is currently the Director of Clinical Research at Nutramax Laboratories. Today, he'll be telling us about his journey and his work in the field of canine performance. Please join me in welcoming Dr. Robert Gillette.
Thank you all. Appreciate you coming over here for lunch and joining me for this thing. Believe it or not, one time I was your age, about 50, 60 years, no, 50 years ago. And so I had an interest in animals and started working with dogs. I grew up in Western Kansas. I had retrievers and pointers. Does anybody ever hunt in here? A couple people hunt. Anybody? Okay. Does anybody know what a dog is? There you go. We'll start big. We'll work down. They're a little different than horses and cats. But I've been working with dogs for a long time, and thought we might kind of introduce you to some of the ways that chemistry plays a role in some of the things we do. Oh, I do this one here. All right, the first thing you have to do is recognize that some of these animals are athletic dogs, and they're actually performing things at athletic levels. And here's anybody ever played basketball? Few of you. So basketball, well, okay, there's another one. Has anybody ever ran a 100-yard dash? Few of you? Has anybody ever ran a marathon? We do it all. So the thing about that is each one of that is a different physiological strain or stress. If I'm running for 100 yards or 100 meters, I'm all out for 100 meters, and maybe that takes me 10, 15, 20 seconds, right? If I'm playing basketball, I'm playing for 45 minutes to an hour, but I'm sprinting up and down. So I have multiple sprint bouts within an hour time period. If I'm running a marathon, that could be 1, 2, 3 hours long. Each of those utilizes different energy systems in the body. And so we have to plan and train for that. So in this little picture here, we got different kinds of athletes. We have a greyhound who's a sprint athlete. I've got sled dogs who are definitely endurance athletes. The hunting dogs kind of fall in with the endurance dogs because they may run anywhere from 2 to 3 or 8 hours. The upper right hand corner there is a detection dog with the military. They may have to work 10 hours a day depending on their need. Anytime you're dealing with an athlete or trying to condition a body, prepare for something, you have to understand the whole body's involved. I mean, if you go out there and try and run a marathon and don't have a heart, it's not going to work. So you need all of it, and it's all got to work together. What's nice about conditioning and training is you find ways to optimize the systems as they work all as one. So in a sense, we have bones provide the structures. Muscles are what creates movement. Nerves is what stimulates that movement. And then all the other body parts support that. So to understand how complex movement is, you all remember when you learned how to walk? No, no one remembers that. But there was a time that you couldn't walk. In fact, you couldn't even get up on all fours. You just laid there. So movement is a learned process, and we forget that sometimes. If you get injured and you need to rehabilitate something, we're re-educating the body to this new structure. So I set about trying to identify ways to understand exercise physiology and how it applies to the dog. I've worked with sled dogs up in Alaska, Montana, and Maine. I've worked with greyhounds all throughout the country. We've worked with pointers all throughout the country. And then I did a lot of work with the military, which was international as well. So one of the things to start with is oxygen. I guess you guys understand that. And I'm trying to tie this back into chemistry. O2 is oxygen, carbon dioxide is CO2. And just to understand how complex it is to get oxygen from the air to the muscles, it's pretty interesting. So you need to understand that within red blood cells, that's what carries oxygen throughout the body. So when oxygen goes into your lung, the little red blood cell will go by a lung cell, transfer oxygen to it, and take it to the muscle tissues. And it's not just like the concierge says, hey, come on into the red blood cell. It's actually a chemical process. Well, heme is the component of red blood cells that carries the oxygen. And heme it has 4 iron molecules in it. And iron molecules are a +2. Oxygen is a -2, so it's a natural fit. So then there actually anybody here taking chemistry? That's great, because I like chemistry, I like physics. That's what really kind of got me into the science field. So there's a reason to learn these things. So partial pressures is one of them. Up in the lungs, when the blood goes by it, there's a partial pressure where O2 is much greater than what the amount of oxygen is in the red blood cell. So it's not that it forces it, but it drags oxygen into the red cell. As it goes around the body, down to the muscle tissues, our muscles that we're working and doing everything with, there's a different partial pressure gradient. And so oxygen flows from the red blood cell into the muscle, and carbon dioxide leaves the muscle and goes into the red blood cell and back into this nice circuitous route. From an exercise standpoint, we need to understand that a little further. There's actually an affinity. Certain scenarios make oxygen want to hold tight to the blood cell. Other scenarios want the oxygen to be released from the blood cell. Has anybody ever done any kind of exercise ever? There you go, great. Okay, so you got to understand in the first 10 to 20 minutes, you're utilizing all your inside energy stores, or you're utilizing anaerobic capacity. After 20 minutes, you start kicking into aerobic capacity. Once your muscles start to get warmed up and are working, they get warmer, and the muscles themselves get warmer. The other thing that happens is there's an increase in CO2 and pH. So there's another reason to learn chemistry, because it applies to how this is going to get back to the tissues. So after a period of work, let me see here. After a period of work, your muscles get warm and they actually become a little bit acidic. That's great, because your saturation point will move to the right, and it makes the blood cells release oxygen. So now at your muscle tissues, they're saying, I need more oxygen, and your body designs it so that it'll just take more oxygen. So it's what's kind of neat about the body's metabolism. It's the way it all works together like this. So we got general metabolism, and then we have performance needs. You know, even when you're sitting right here, it takes energy to sit. I mean, you're not falling down off your chairs, and you're also eating. That takes energy. That takes energy, but energy is taken in. So that's energy, and it's one level. Now, if you're debilitated and very sick, it may be hard just to sit up to eat. So conditioning, I'm saying I'm very conditioned, I'm not conditioned. It's all relative to a certain state. Some people say I wanted to walk a mile. That may fatigue me. But a postman or postwoman who walks 5 or 10 miles a day, a mile's nothing to them. See, it's conditioning is all relative to the needs of the body. But when we get into performance, we know that the energy is going to be above what the body's normally doing at rest. So then we need to figure out, okay, what kind of energy is going to be utilized and how's it going to be used, so I can prep the body for it. So I guess you guys are eating pizza. So pizza's carbohydrate. Is there some meat on there? So then we got some protein. I'm sure there's some fat in there somewhere. So those are your three basic energies, right? And so you have, they're all taken in. Glucose is typically, glucose or carbohydrate will become glucose, protein becomes amino acids, and fats become triglycerides. Carbohydrates are generally stored in the liver and the muscles, protein stored in the muscles themselves, and fat is obviously stored in fat areas. But the energy needed for work or performance is ATP. You guys ever heard of ATP and ADP and all that? All right. Well, ATP is the key to it. And I'm not going to test you on the Krebs cycle or citric acid cycle, but there's really reasons for that happens in the body. Is that all these different compounds are broken down and can fit into the citric acid cycle or Krebs cycle. And most of your energy right now is utilizing that as an energy source, mostly fat. Now, let's figure out how the dog does this, because dog is is a special species. It's one of the few species, actually it's the only species, that is able to utilize fat as an energy source compared to all the other species. Sometimes if you guys have had any kind of track or athletic events, you've heard of slow twitch fibers and fast twitch fibers, type 1, type 2B, and all that kind of stuff. Dogs don't have the glycolytic type 2B fibers, and they're the only species that don't. They're very efficient, and a lot of it's going to become, they're supposed to outrun the prey. They have almost 3 times the number of mitochondria in their muscles that we have. One time the government, there was a guy doing research on sled dogs and how efficient they could go forever. And the guy got a bunch of money to figure out, okay, can we make the American soldier like the sled dogs in endurance? Well, the people in the community that didn't get the research money were all upset because we'll just give them more mitochondria, they could do it, but you can't change the genetics of that. But they were very efficient at utilizing fat as an energy source. But you have to condition that. You have to, the energy for burning fat as a source is very complex, and it involves a lot of enzymes. And so you can't just go out and do it. A lot of times, if you go out and do something, you can do anything for 15 to 20 minutes. Once you get past that 20, 30-minute mark, that's where you're going to start to get fatigued, unless you're conditioned for it. So our goals are, we want to maintain conditioning of all the body systems, make sure that the kidneys can get the stuff out of there, the lungs are efficient about getting the oxygen in and out. I want to put energy at the pools or the locations that they need it. Then I want to maximize the replenishment of those pools at the right times. So we talked a little bit about it. There are strength and power events, and then there are endurance events. Short duration, typically less than 2 minutes at a super maximal output, would be a strength or power activity. Endurance is usually longer than 2 to 4 minutes at less than 90% max. What I really want to do is make it so the dog, when they're working, never gets into a negative metabolic state, because once they do that, they have to recover. You guys ever done any kind of work anywhere that when you got done the next day, you're like, oh, man, that wore me out? That means you tapped into that area that you actually overworked. So what I want to do is condition the dog so it never gets to that point. If I never have to recover, then the dog can do whatever it needs to do. Now, typically, if I'm utilizing dogs that are in the power sprint, they're going to get into negative metabolism no matter what. But typically, they do that for such a short amount of time that has minimal effect on the body. When you get into bird dogs, detection dogs, sled dogs, foxhounds, most of their time is spent here. So I just want to find a way that I can get them working in the green area instead of the red. This was a study we did related to dogs, where we said, okay, we took a group of detection dogs. We took half of them were going to be conditioned and exercised in addition to their normal detection training. They were all bomb dogs. And every dog has to be certified at a certain level. And what we did is we took them down to the finest level that they could. So no matter what, I want you to understand, all these dogs were safe and good detection dogs. But we split them into 2 groups. One group got an exercise program for a 2-month period, and the other group did not. Then we threw them on planes. We flew them up from Atlanta down to Florida. And we put them out to work because we wanted to identify if a dog has to get deployed very quickly, can it handle the work it needs to when it gets to the place it's supposed to work? What we found was that the dogs that were conditioned had less stress related to the transport. the flying. And all these dogs had never flown before, but the dogs that had been conditioned weren't stressed as much as the ones that were unconditioned. The other thing we found was the dogs that were conditioned, once they got down there, could find more of the test material than the other dogs. So the conditioning itself enhanced the ability of the dogs to work. So here's a little more chemistry. Need to understand that muscles are made up of actin and myosin protein chains, and they need energy to contract. ATP is the energy that is needed when calcium goes into the muscle cell. That allows myosin to attach to actin. And then the ATP energy is what bends the head and allows contraction to occur. And then when it gets done, the muscle, that ATP, or the myosin has to detach, and that takes ATP. So if you think about it, that's what's cool about dogs. They have 3 times the amount of ATP, and it's actually within the muscle cell in this area here. And they're designed to use the aerobic energy all right in here. So if we think about that from a time standpoint, sprint dogs, greyhounds, dog pull events, dock dog, the ones that jump up on the air, they're using extreme amounts of energy. They're all going to fall in with this less than 1 minute of activity. And then once you hit about 1 minute to 2 minutes, you start tapping into anaerobic energy. And then right around 4 minutes, you're burning oxidative energy, but you're utilizing utilizing liver glycogen instead of muscle or fat. And once you hit 20 minutes, that's when you start utilizing fat as an energy source. So anytime you're conditioning or training a dog, if you're doing it less than 15 to 20 minutes, you're never going to tap into that. I don't know the announcers on CNN, but one time the guy said, you know, we all know detection dogs can only work 15 minutes. Well, he was full of it, because obviously he didn't know detection dogs. Because if you only work a dog for 15 minutes, it's never going to be able to work longer. I wanted to throw a brook at the TV. I was so upset, because the thing was, if a sled dog could only go for 15 minutes and rest, they would never finish that Iditarod. Those dogs run forever. So there's a lot of unknown out there, and you got to kind of watch out for that. So when I'm preparing a dog that's using multiple tasks, so like a lot of the military or detection dogs or police dogs, we have to start what we call cross training, and we build the body for it. So we go back to this is the chemistry where we need the ATP. And what I really want to do is get the body to start using the aerobic energy as its energy source. So all these chemical reactions we're talking about are exothermic. You guys heard that before? That means the energy creates heat. And that means that the body's actually going to get hotter when it's doing these things. These are 2 Weimaraners before their 1.3 mile walk and afterwards. In the night, it was 65 degrees that night. And these are thermographic images to show you where the heat's coming from. So dogs are different than us. And somebody, I've asked you if you know what a dog is. Anybody got dogs? All right. Do you ever see them sweat? No, they don't sweat. Now, sometimes they'll sweat between their pads, but in general, most of the heat comes either through the respiratory tract or coming off the body. So that means that they have to manage their temperature different than we do. So our temperature is 98 degrees Fahrenheit. Dogs' temperature is typically 101.5. When dogs are working, you're going to see these different temperatures, and it's quite common. When I ran my greyhounds in the field, after about 6 to 7 seconds of work, they would increase their temperature from 101 up to 106. These are retrievers working for about 10 minutes out in the field, going from 101 up to 106. These are sled dogs that ran for about 20 minutes. They went from 101 all the way up to 109. Typically in veterinary medicine, we worry that once they hit 106, that we need to do something. But if you've ever worked with detection dogs or hunting dogs or whatever, you know 106 happens a lot. The dog just has to be prepared to manage that. If a dog's in a car and the environment's hotter than that dog can't cool off, that's bad. These dogs that are conditioned to handle these things, it's not that it's not bad, but their body can handle these things. They're tough. So you also have to recognize that there is a macro environment and a micro environment. there's a macro. We're in the city of Lancaster. We're at a school called University of South Carolina, Lancaster. But you're in this room. Now you guys are at tables, and actually around you is micro spaces. So if I can keep the microenvironment around the dog cool, like if I've got a dog and I'm out hunting with that dog, every, I don't know, half hour to hour, I give that dog some ice or have it go into the shade somehow, I'll actually cool that dog down. So if we look at these temperatures that we're reaching here, 106, 108, I want to find a way to prevent that. One way to do that is the source of the food I'm having that dog burn. If I can condition the dog to utilize fat as an energy source and use fat as an intake, he actually will be cooler for the whole time they're working. Once the dog, the order is they burn carbohydrate, then they burn fat, then they burn protein. If they're burning carbohydrate and then they don't have the capability to burn fat, now they're burning protein, which is a catabolic. They're actually eating themselves up to get the energy. And that's a very, very hot burn. And so that tends to increase temperatures in dogs. If I can find a way to get the dog to utilize fat as an energy source the whole time that they're working, typically they don't get hot. So that all boils down to conditioning and right energy sources. I was given a task, could I get dogs to work 10 hours a day and temperatures up to 120 degrees for 9 days straight, and then they would have 5 days off, and they would do this for 3 months, and they couldn't have the dogs get sick, overheat, or get injured. So what I did is I developed a system where we can condition the dogs, utilize the right kind of diet, and they could handle it. We did another study where we looked at where we had 18 different dogs, detection dogs again. We put them in 3 groups. They all had an exercise conditioning program. Now, what's kind of cool about this is I like hunting dogs, but I used money from the government to help me understand more about detection and olfaction. We learned a lot about the olfaction capacity of dogs in this study. But the thing is, we had one dog that was high in animal fat. The dog food was that way. One was low fat and the other one was low fat, and we added corn oil. Now it's kind of funny because there's no real income related to corn oil. There's no company that sells it. There's nothing about it. But I learned a long time ago that the dogs could benefit once we supplement with it. So we had these 3 different diets and we'd flip them every few weeks. What we found was the dogs that were on the corn oil diet had better olfactory capacity than the ones that were on the 2 other diets. We found the dogs that were on the low fat diet couldn't handle the exercise or the effort the dogs on the higher fat diet was. So it's real important that when you're dealing with these performance dogs, that they get the right kind of nutrition for them to perform. So I think I hit, am I right, 12:45? All right, so I'm happy to take any questions, or I can go a little further on some other things, but I wanted to make sure that we get you back in time for your classes. I know you'd be excited about that. Yep.
So what do you think it was about the corn oil versus the animal fat? Because when you think about dogs, we always are told that they're carnivores. And so why does the plant fat, cool their bodies better than the
So in that sense, it really wasn't, what it was there was a low fat diet which had animal fat in it. Then we added this as a topper. When I was in practice and we were trying to find ways to supplement vitamin E to performance dogs as a cellular stability supplement, that they all seemed, when I would give it to the bird dogs, my clientele that were bird dogs, they'd all come back and they were just thinking these dogs would do anything. So it's great. And when I talked to the animal nutritionists, they said that's the wrong kind of fat. And so actually I made a bet with this nutritionist at Cornell. I was at Auburn and he was at Cornell. We bet $1. I said, I think corn oil and a beer, but can't talk about that. But we had $1 bet, and we come to find out that corn oil actually did enhance it compared to the other. But you won't really find that out there because it doesn't fit the norm. I think in this one scenario that the corn oil does supply vitamin E, some other components that the other fats don't have, and it might be part related to that.
Okay.
I mean, you understand fats are very complex. There's a lot of things
Yeah.
there.
I mean, so it's not a function of the chain length or the degree of unsaturation in the. oil?
There is, and that's why you do have to have some of that animal fat in there. And then it's like, it wasn't that corn oil. Well, there's another problem. So I brought this up to some bird dog guys one time. And he fed low fat diet and he was contracted to feed this one certain diet. And he wanted to increase the fat percent. And so he started adding 6 cups of corn oil to each dog's food. Now, I don't know if you know how much 6 cups of corn oil is. And he called me up. He says, my dogs aren't working good. And so I went out there and they were all sitting there and their rear ends were all dirty because this corn oil was just coming out of the back end of the dogs. And so we got to reduce the amount of corn oil and find another way to do that. So it was, I mean, you can give too much. Obviously, you can give too much. Sorry to make that right while you're eating stuff, but any other questions? Yeah.
What do you specifically do at Nutramax? What are you working on?
So my day job, I'm head of clinical research out at Nutramax, where Nutramax is a supplement company. We have veterinary products or animal products, and we have consumer human products. It was started by where Dr. Bob Henderson developed a Cosamin, which was to help joints. And then his son Todd started putting into dogs and started seeing improvement in the dogs. And from that, they developed this company that's out here today. And I oversee the research for that company. Any other questions? All right,
Can you tell us a little bit about the research, or is it all proprietary?
it's good. No, we do. It depends what's out there. You know, there'll be a compound. I mean, what's kind of neat about Nutramax is that in big pharma, you have to do a lot of federal regulatory testing. And so in supplements, you don't necessarily need to do that. But because Dr. Bob Henderson came from pharma, he makes us stay within those standards. The reason I say that is that if there is a compound, not a compound, if there is a substance out there that might have shown some benefits somewhere, a supplement, an herb, or it's kind of, I don't want to say it's holistic, but it's kind of integrative medicine at its finest. If they find this herb that has been doing something for a long time in some sort of area, and we think it might benefit an animal or a human, then we'll bring it in and we'll look at it. We'll do a background search on it. If we think it's something that we may go for, then I would reach out to an academic institution somewhere around the country that is dealing with those types of issues. And then we partner with them. And then we work through their research group to do whatever we need to do research like that.
Okay,
Yeah.
nice.
And we do partner with a lot of academic groups. So if you have any kind of issues, I'd be happy to talk. I don't know anybody's got any interest around here, but happy to work with them.
Do the animals go into like ketosis when they are burning their fat, just like humans that go on those keto diets?
No, because they're burning them in a different way. Keto is when you're burning it in a negative way.
Okay.
This is pulling the fat out, and so it's not tapping into it. And you understand, it's only dogs. Horses, antelopes, Thompson's gazelles, leopards, cheetahs. I've partnered with a group out of South Africa where we're looking at how to assess metabolism of cheetahs. They're totally different than dogs.
You work with a lot of colleges and universities?
Yeah, right now we have, I think, probably 12 different on the veterinary side, and we have 8 different academic groups we're working on the consumer side. Yeah. All right, I guess they want to take a picture of y'all. So
We do. We want to get a good picture before everybody goes to their 1 o'clock classes.
Thank you so much.
no problem. Thank you. He's over where you need me to go.